Hello and welcome to Honors Function. In this second video on the algebra of function, we're going to be looking at a way to combine two functions that does not have an analogous operation in the set of real number. It's called the composition of two functions. Let's start. So again, if I want to combine function, I need to take two functions. So let's take f and g. In this first approach to composition of function, we're going to be looking at function as something that carries an element from the domain into the co-domain. You know, a function is three objects, a rule of assignment, a domain, and a co-domain. Okay? So suppose you have some elements right here. Let me call them A, B, C, D, E. Okay? And suppose these elements are carried in the co-domain with the function f. So this is going to be f of A. Then we're going to have an f of B, and maybe f of C will be going at the same place as B. It's possible. It doesn't make it not a function. And then we're going to have an f of D right here. And then finally an f of E right there. Okay, so we're looking at the function that carries element from the set that we can call A into the set that we can call B. Now, once you land in this set, it is possible to find here a second function that is going to take elements from that set into a third set that we can call C, for example, and the second function would be G. Now, this second function does not need to have a domain the entire set B. Maybe the domain of that function is just going to be right here. So let's suppose this right here, this is a domain of G, okay? Domain of G. So let's see what happened. And also G, let me show you what G does. So G is going to carry this element here, and that's going to be G of f of A. And then it's going to carry this element here, and that's going to be G of f of B. And this one, it will carry it further, G of f of C. But it will not be able to carry f of E because it is not, f of E is not in the domain of G right here, okay? So now what we can do, we can omit this set right here and look at the function that goes directly from here to there. The way we call this function is G composed with f. You can read that as G of f or G round f also, okay? G composed with f, G of f, or G round f. Okay, so it's another rule of combining function. This is the third function. What does it do? It will take A and will carry it right here. It will take B and carry it right here. C happens to be carried at the same place right here, and then D right here. It will not take E. E is not in the domain. E is not in the domain of the function G of f, G round f, okay? This is called the composition function. So another way of presenting this is with the function notation to say that f is a function from A to B. You remember this way of presenting a function. G is going to be a function, let's say, from B to C. If we have this, then we can define a third function that is called G of f, okay? So you got to be careful because you're going to first start with f, okay? And G of f is going to be going from A to C. It's going to take an x. The notation I'm using here is a formal notation for a function, okay? With this kind of arrow here and just a simple arrow right there. X, and it's going to go to G round f of x. And by definition, this is G of f of x, okay? This is actually the definition of the composition of two functions. So before we look at the domains, and this diagram is going to help us understand what's a domain of the composition function right here, why an element is not in the domain. Before we talk about the domain, let's go over the first example. Alright, I'm asking you to find the expression of three functions in example number 1. Let's start. What is the expression of G of f at x? Well, by definition, this is just g of f of x right here. So instead of the input x, I have the input f of x. So I have negative f of x squared, okay? I'm looking at this expression, plus 2 times f of x, and then minus 1. So what is this? This is negative, so 2x plus 3 squared, plus 2 times 2x plus 3, minus 1. We would need to expand that, so negative 4x squared, 6 times 2, 12, minus 12x, 9 minus 9, plus 4x plus 6 minus 1. And so we have negative 4x squared. The x's I have minus 8x, and then plus 6 minus 9 minus 3 minus 4. Here we go. This is the rule of assignment for g of f. Let's look at f of g now. F of g at x. So by definition, this is f of g of x. So what is, I'm looking at this one now, right? And it's 2 times, instead of x, it's g of x plus 3. So that's going to be a bit quicker. So we have negative 2x squared plus 4x. And then I multiply this by 2, minus 2 plus 3 plus 1. Okay, I went a little bit quick right here. I hope I didn't make a mistake. Let's look now at f of f. F of x. So this is again, by definition, this is f of x. And so it's not difficult. Inside f right here, you plug, for x, you plug f of x. So it's 2 times f of x plus 3. So it is 2 times, and then f of x, 2x plus 3. Here I took a little bit longer. So it is 4x plus 6 plus 3 plus 9. Okay? Let me go over the second example with you. So I'm going over the second example, and I'm going to let you do example number 3. Okay? So let's find the expression of g of f of x. So this is g of f of x. All right. Let's go. So I'm looking at g of x. I'm looking at this. And instead of x, I have to write f of x. So this time I'm going to do it directly, okay? So on top I have x minus 1 over x plus 2, that's f of x, divided by 2 times, and then f of x, x minus 1 over x plus 2 minus 5. So by this time I think you know what I do right here. I multiply both sides by the common denominator. It's a little bit faster if you are careful and don't make a mistake. So on top I just have x minus 1. At the bottom I have, so this will distribute there, it's going to simplify, but I still need to multiply by 2. So I have 2x minus 2 right here. And then I multiply this by negative 5. So minus 5x minus 10. And so it is x minus 1 over negative 3x minus 12. That's it, okay? I don't think I've made a mistake. You see, it's pretty quick when you do it like that. Let's do a f round g, or f of g. So f round g of x is just f of g of x. And so I'm going to be looking at the expression of f of x, and I'm going to replace all the x's by the expression for g of x. So x minus 1, so x over 2x minus 5 minus 1 over x plus 2, so x over 2x minus 5 plus 2. Okay? So hey, same thing there. Multiply both sides by 2x minus 5. It's going to be super quick. 2x minus 5 right here. And so we have what? We have x, right? Cancel this with this. Minus 2x plus 5. Careful with the negative sign here. Over x plus 4x minus 10. Okay? And so it is negative x plus 5 over 5x minus 10. That's it. All right. So let me do the last one. F of f. So this is a little bit more messed up. So f of x right here, it is equal to f of x. All right, so let's take the expression of f of x. So it is x minus 1 over x plus 2 minus 1 over, let me go a little bit here, over, so x minus 1 over x plus 2 plus 2. All right, so now let's multiply by x plus 2, x plus 2, and we have, so x minus 1 minus x minus 2 over x minus 1 plus 2x plus 4. So it is negative 3 over 3x plus 3. Oh, I can simplify by 3 everything, and I should. Negative 1 over x plus 1. I think I haven't made a mistake, okay? Please check my work, but I think this is correct. Let's go over more examples. So in the first two examples, I gave you the expression for functions right here, the expression of f and the expression of g. But you know there are other ways of giving a function. You can look at a function graphically, and you can look at the function numerically. So let's go over two other examples with composition and various ways to look at a function. So I'm looking now at example number 4. I'm giving you the graph of two functions. So you do not have the expression. I'm just giving you the graph, and I'm asking you to find some of the output of the composition of g of f, or of f of g, or of something more complicated, okay? So it's really not difficult. You just got to follow input, output. So this by definition is g of f at negative 4. Well, what is f at negative 4? So you go to negative 4. F at negative 4 is 7, right? 7. So it is g of 7. And g of 7 is, it is 5. So it is 5. That's it. That's how you do it, okay? Here, let me take something that seems a little bit more complicated. Let me look at this one right here. So this is g of f at 0. Of course, you can compose several times. So f at 0 is negative 1. So it's g of g at negative 1. G of negative 1 is negative 3. So it is g at negative 3. And g at negative 3 is negative 5. And so it is g of negative 5. That's it. I'm going to let you finish this one. Let's look at a numerical approach to functions. So really, this is the same thing, but this time we have a table instead of a graph. Well, it's really not a big deal. All right, let's look at this one, for example, g of f at 1. So what is f of 1? F of 1 is negative 4, so it is g at negative 4. And g at negative 4 is 0, so it is 0. That's it. It's that simple here. Let's do g of 2 right here. G of 2. So let me erase that. All right, where's my input 2? If my input is 2, g of 2 is negative 1, so it's g at negative 1. And g at negative 1 is 7, so it is 7. You see? Very, very straightforward. All right, now let's talk about the domain. So I'm going to go back to the diagram I drew at the beginning. What did we say when we looked at the diagram? We said that A, B, C, and D were all in the domain of g of f, okay, because they all go somewhere in C with the function g of f, right? They all land somewhere there. But E does not. Why? Because E is not in the domain of G. It's in the codomain of f, of course, okay? It goes right here in the codomain of f, but it doesn't land in the domain of G. So how can we write this? We could say that the domain of g of f, well, what do you need to do first to x? Well, the first thing that you need to do is put it into f, right? If you cannot do that, forget it. You're not going to be able to carry it into the third set right here, into set C, okay? So you have to be in the domain of f. That's a necessity. You have to be in the domain of f. But then what? Then you got to make sure, that all these x's that you have right here, x, such that f of x is in the domain of G. okay, you got to make sure that f of x lands in the domain of G. You see this one right here? It doesn't land in the domain of G, and that's why it's not in the domain of G of f. So you got to take the intersection right here, okay? Another way of saying that would be you got to make sure you're in the domain of f, and from there you remove all the x's such that f of x doesn't land in the domain of G. You remove them, okay? So if you remove them, all the ones that are left in here are going to be landing. Oops, doesn't land. I got to cross it out, okay? All the ones that will be left in that set will be landing in the domain of G, and so you can carry them further. Now this is a little bit complicated. I propose in my notes, I propose a much more satisfying way to do that. It is possible to take this intersection, okay? It is possible to take this intersection. You can study this. This you need to study in any case. And then you can look at that right here. What's that set right here? And then you take the intersection of both sets. We can do that theoretically, but there's a much faster way to do things. Here we go. Let's go over what I'm saying in my notes. So in my notes, to look at the domain of f of G, I'm sorry, there's a mistake right here. This should have been G of f, okay? So please change it. It's G of f, not f of G. The first function that you do is f, okay? To look at the domain of G of f, here's what you can do. Two-step. First, you gotta be in the domain of f, okay? When you look at the function G of f, x, the first thing that happens to x is that it's thrown into f. So it's got to be in the domain of f, okay? And second thing, you just look at the expression of G of f of x, and you make sure it is defined. Just the expression. What does it mean? It means, do you have a square root? Do you have a log? Do you have a ratio? You know, the way we look at definition, domain of definitions. Let me show you how to apply this on an example. So let's look at example number 6, for example. I want f of G and the domain of f of G. So what is the expression of f of G? F of G at x is f of G of x. And so you plug G of x inside f. So it's 4 divided by, and here I'm going to square G of x. So x plus 3 squared minus 1. So it is 4 divided by x plus 3 minus 1. So it is 4 divided by x plus 2. This is the expression for f of G. Okay? Now, what is a domain? What's the first thing that you do to x? You throw it inside G. So you have to be, the first condition is x must be in the domain of G. Okay? Now the domain of G is pretty simple. You want to make sure that x plus 3 is positive or equal to 0. And so that means x is above or equal to negative 3. Okay? So the domain of G is negative 3 infinity. Right here. But then what happens there? The second thing is just look at the expression 4 over x plus 2, and you got to make sure it's defined. Now just this, okay? You just need to look at this expression. This is defined when? Defined if x plus 2 is not 0. So if x is not negative 2, okay? And so you can see that negative 2 happens to be there. And so the domain of f of G is what? It's negative 3 and then 2 negative 2, which you remove, right? Because you cannot be equal to negative 2. Negative 2 infinity, all right? Now, you can see that just looking at this would not give you this, right? You don't understand. If you just look at this, you don't understand why you have to be above negative 3, all right? Okay, let's talk about the last thing now, which is how to do composition of functions with your calculator. You will see it's very simple. So I'm going to be looking at two functions, the square root of x plus 3 and x squared plus 1. And I will want to do, for example, I'm looking at G of f. Okay, so let's take the calculator. All right, let's enter the function in y1 and y2. So 1 is the square root of x plus 3, so x plus 3. And the second function is x squared plus 1, so x squared plus 1. Here we go. Now the first one is f and the second one is g, and I want g of f. So I need y2 of y1, so check it out. I'm going right here, vars, y vars, function, y2 of, so this is a parenthesis, and then y1. Y vars, enter, y1, right here, y2 of y1. That's it. So let's actually not plot any of the two functions. So I don't want to plot this right here, enter. I don't want to plot this, enter. Okay, so now let's do a zoom standard, zoom 6, zoom standard, and let's look at the graph. Wow, it looks like a straight line, right? It definitely looks like a straight line, except that it's not a line, it is a ray, right? Because it begins right here, it's a ray. Let's try to quickly understand what's going on here. So if you do g of f of x, what are you going to have? You're going to have, you take f of x, and then what happens to it? You square it, and you add 1 to it. So it is x plus 3 plus 1, x plus 4. So it's like a straight line, y equals x plus 4, but you start with f, you got to be in the domain of f, x has to be above -3, okay? So it's like a straight line, but it starts at -3. That's it. I hope it's clear, this composition of function, very, very important rule. Thank you for watching.